For this video, we're going to keep looking at systems of equations, and we're going to look at our nonlinear system. So remember, with nonlinear, we're not going to worry about elimination. We're going to leave that for when you just have two linear equations. So we're going to use either substitution or graphing, and we'll graph by hand as well as using the calculator. So to begin with, I have a linear and a quadratic system, and we're going to do this one by substitution. Keep in mind whenever you're solving these systems that you need to keep an idea of how many solutions you could possibly have. So remember, linear and quadratic, it's a line and a U. So I could have, two solutions where it crosses twice, or I could have no solution, right? Or I could potentially have one where maybe you have a vertical line, or if it just happens to touch at that one point that's tangent to the U. So I can have no solution, one solution, or two. I can't have more than two, and obviously can't have less than none. Okay, so we're going to keep that in mind when we solve. And remember, your solution to your system of equations is going to be a point. So I need an x and a y. So I don't stop as soon as I find x or y. I have to make sure I plug it back in to get both. So for this one, I've already got y by itself. So I'm going to take what I know y is in the first equation and plug it into the second equation. So I end up with 2x plus, and I would always use parentheses. That way, if you do have to do some distributing, it's plain and out in front in sight and everything. All right, so now I just plugged in x squared minus x minus 6 for y. And I don't have anything to distribute. It's positive. So all I'm going to do from here is go ahead and combine my like terms. So nothing goes with x squared. And then I have 2x and negative x, and that gives me a positive x. And then I have the minus 6 equals negative 4. And then to solve this, because it's a quadratic, I need to set it equal to 0. So I'm going to add 4 to both sides. So we get x squared plus x minus 2 equals 0. This is factorable. It's a plain Jane trinomial, so I want to multiply to negative 2, but add to 1. And so my only factors of 2 are 2 and 1. And I need one positive, one negative. So I'm going to have a positive 2, negative 1. And then to solve, I just change their signs. So I get x equals negative 2 and x equals positive 1. So now I have two solutions, but I need to plug them back in to get my y values because I have the x values. So you can pick any equation you want. I'm just going to use the first one because it's y equals. So for x equals 2, or negative 2, I have negative 2 squared minus negative 2 minus 6. Negative 2 squared is 4, minus a negative becomes plus. So 4 plus 2 is 6, minus 6, 0. So one of my answers is negative 2, 0. For the second one, I'm going to plug in 1. So we get 1 squared minus 1 minus 6. So 1 squared is 1. 1 minus 1 is 0, minus 6 is negative 6. So my second answer is 1, negative 6. Okay, for the next one, I've got two quadratics. So if I think about the number of solutions I could have, two intersections. I could have one intersection. I could have no intersection. And then I could have the same quadratic, which would be all real numbers. So I could have 0, 1, 2, or all real numbers. So for this one, the first one's in intercept form. So to graph it in intercept form, first I'm going to graph my intercept. So I know because it's x plus 3 and x minus 2, I have intercepts at negative 3, positive 2. Right, then I need my vertex. That's the most important point on my quadratic. So to find the vertex, we got to find p plus q over 2 and then plug that back in. So that's going to be negative 3 and positive 2 over 2, which is negative 1/2. So the middle of my graph is at negative 1/2. And then I plug that back in. So we have negative 1/2 plus 3 times negative 1/2 minus 2. 3, where the denominator of 2 is 6 over 2. So negative 1 plus 6 is a positive 5 over 2. And 2, the denominator of 2 is 4 over 2. So negative 1/2 minus 4 over 2 is negative 5 over 2, which gives me negative 25 over 4. And that is negative 6 1/4. So that's right about here. All right, now keep in mind when you're doing quadratics, we need 3 points to be able to graph it, and I might need to plug in more points later once I see what my second graph looks like, but we'll see what happens. So for this one, I'm going to start by going ahead and factoring it. All right, so I've got negative 2 on the outside, and that leaves me with x squared plus x minus 6. This is factorable. It's a plain Jane trinomial, so I want to multiply to negative 6, but add to 1, so that's going to be 3 and 2, and my bigger one has to be positive. So there's my factored form. That right off the bat tells me that I have x-intercepts at -3 and +2, which is where I had x-intercepts before. All right, now I'm going to go ahead and finish my graph, even though I know where my intersections are going to be. So going back to standard form, to graph in standard form, you got to find -b/2a. So I've got -2, which is +2, over 2 times -2, -4. So I'm at -1/2. Plugging that back in. -1/2 squared is 1/4. -2 times 1/4 is -1/2. -2 times -1/2 is a +1. All right, so that ends up giving us 12.5, which is 25/2. So that's way up here. We'll say that this is 12.5. All right, so there's my third point, and I can connect. So my answer for this one ends up being -3, and 2, And for the last one, we're actually going to use the calculator to graph, because usually with exponential, that's the easiest route anyways, but you can use it for any of these systems. So here's the calculator. I'm going to go to y equals, and in y1, I'm going to type it in just like I see it. So I got negative, and then parentheses, x plus 1, caret 2, and then plus 2. And then y2, we have 2, caret x. So I'm going to go to my graph. Again, make sure before you find the intersection that you can see the intersection in your window, which I can. I actually have 2 intersections here. Right? So I'm going to go second trace, number 5, to find the intersect. And the first time, I'm just going to press enter, enter, enter. Let it guess. So it tells me that one of mine is at 0, 1. So we'll write that down. That's one solution. Then to find the second one, I'm going to go back to second trace to get to that intersect option, but I need to tell the calculator that I want the other one, so I'm just going to scroll closer to it and then do enter, 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 just to tell it to find the second one. All right, so this one I'm going to round to the hundredth, so we've got -2.34, -2.34, and then if we look at the y value, we've got 0.197, which rounds to 0.2. Alright, so that it's easy on the calculator. You just go second trace 5, enter, 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 and you just have to do it more than once if you have more than one intersection. So the calculator does all the work for you.